Yes, this is Raghavan from All Force Educational Institutions. I welcome you for Chemistry e-learning program, session 13. So in this session chemistry, in the last session we completed the radius derivation and energy of the electron in the orbit, that is as per Bohr's atomic model we have done. That is radius of the orbit, according to the Bohr's, it is radius of the first orbit of hydrogen is determined as 0.529 angstroms, and nth orbit of hydrogen is done, and species like hydrogen nth orbit is also completed. Next, energy of the electron in the nth orbit of hydrogen atom is given by the expression, that is energy of the electron in the nth orbit, that is En is equals to minus 2 pi square m z square e to the power 4 by n square h square. Okay, substituting the value of all the contents, the energy of the electron in the first orbit of hydrogen atom is calculated as minus 13.6 electron volts, or it is equals to minus 2.18 into 10 to the power 11 ergs per atom, or it is equals to minus 2.18 into 10 to the power 18 joules, or it is equals to minus 1312, that is 1312 kilojoules, or it is equals to minus 313.6 kilocalories. So these are all energy of the electron in the first orbit, energy of the electron in the first orbit of hydrogen atom. Okay, so now this is the basic energy of the electron in any orbit of species containing one electron. Okay, so where pi is equals to 22 by 7, that is 3.14 mass of the electron. Okay, mass of the electron, for example, let us consider energy of the electron in the first orbit of hydrogen atom, then minus 2 into 3.14 into, that is 3.14 whole square, mass of the electron 9.1 into 10 to the power minus 28 grams into z square, that is hydrogen atomic number is 1, into E square, that is charge on the electron, that is 6, that is 1 point, or you can say, okay, that is in CGS units, 4.8 into 10 to the power minus 10 ESU divided by, that is energy of the electron in the first orbit of hydrogen atom. Okay, divided by n first orbit of hydrogen into Planck's constant value 6.625 into 10 to the power minus 27 erg seconds. So substituting all the values, so energy of the electron in the first orbit of hydrogen atom will get as minus 2.18 into 10 to the power 11 erg seconds. Okay, that is like that we can calculate energy of the electron in the first orbit. Okay, and energy of the electron in the nth orbit also we can calculate. This is the basic equation. So by using this we can calculate energy of the electron in the first orbit of hydrogen atom as like this. Okay, and let us find energy of the electron in the nth orbit of hydrogen, that is energy of electron in nth orbit of hydrogen, nth orbit of hydrogen nth orbit of hydrogen, that is equals to minus energy of the electron in the first orbit, energy of the electron in the first orbit by n square, so that is to calculate energy of the electron in the nth orbit of hydrogen atom only. Okay, now let us calculate energy of the electron in the nth orbit of species like hydrogen. Once again, this is energy of the electron in nth orbit of species containing one electron. Okay, that is a basic equation. Now using the contents, we determined energy of the electron in hydrogen atom as like this. Then applying the same equation for the energy of the electron in the nth orbit of hydrogen atom only. Okay, by n square. Now energy of the electron in nth orbit, energy of the electron in nth orbit of species like hydrogen, that means helium plus lithium 2 plus beryllium 3 plus, that means species containing one electron, that is equals to energy of the electron in the first orbit by n square, yes, done, by n square into z square, so this is, yes, into z square. So energy of the electron in the nth orbit of hydrogen atom, important, energy of the electron in the nth orbit of species like hydrogen atom, so that is, these formulas are very important for your objective examination point of view. Okay, this is the complete energy of the electron in the nth orbit of species containing one electron, that may be hydrogen atom or species like He plus ion, lithium 2 plus or beryllium 3 plus ions. That is, calculation of energy is done. Okay, now let us take up the next concept is velocity of the electron. Next concept is velocity of electron in any orbit. Velocity of electron, calculation of velocity of an electron in any orbit. Let us write the heading, calculation of velocity of an electron in any orbit. Yes, calculation of velocity of electron in any orbit. So now, according to, that is Bohr postulates, by Bohr's postulate, that is, angular momentum of an electron is equal to the integral multiple of h by 2 pi. Okay, that is mvr is equals to nh by 2 pi. mvr, angular momentum of the electron, is equal to integral multiple of h by 2 pi. So therefore, let us consider velocity v is equals to nh by 2 pi m r. Okay, so then that is velocity of the electron is equals to nh by 2 pi m r. Then where r is equals to radius of nth orbit, So how we can represent the radius of the nth orbit? radius of nth orbit is equals to n square h square by 4 pi square m z e square. Okay, now substitute radius of nth orbit in the equation, that is in the above equation. Say it is equation 1. Okay, substitute radius of nth orbit in the above equation, or we can say in equation 1. Okay, substitute r value, that is total content of r in this equation. Now v is equals to nh by 2 pi m r, that is in terms of r, n square h square by 4 pi square m z e square. So this is substituted. Now cancel the similar terms we have. So now n, 1 n is cancelled, h, 1 h is cancelled, and pi, 1 pi is cancelled, 2 to the 4. Yes, done. Now velocity is equals to 2 pi m z e square, that is m is cancelled. Okay, now 2 pi z e square by z e square by nh. This is velocity of the electron in the orbit, any orbit. So velocity of electron in any orbit of species containing one electron can be represented given like this: velocity of the electron in the nth orbit, any orbit. Okay, now velocity of the electron in any orbit of species containing one electron can be represented like this. Now velocity of the electron, let us calculate velocity of the electron in the first orbit of hydrogen atom. Velocity of the electron in the first orbit of hydrogen atom, in the first orbit of hydrogen atom, that is equals to, substitute the values, 2 into 3.14 into z, hydrogen atomic number is 1, into e square, charge on the electron, that is CGS units, 4.8 into 10 to the power minus 10 ESU by n orbit 1 into Planck's constant value in ergs 6.625 into 10 to the power minus 27 ergs. So now the velocity of the electron in the first orbit of hydrogen atom, that is equals to, this is equals to, that is 2.188 into 10 to the power 8 centimeters per second. This is velocity of the electron in the first orbit of hydrogen atom, can be calculated like this. This is velocity of the electron in the hydrogen atom, can be calculated like this. So now once again, calculation of velocity of an electron in any orbit of species containing one electron, that should be remembered. So by Bohr postulates, we know that angular momentum of the electron is equal to integral multiple of h by 2 pi. Yes, we understood. And from this, v is equals to nh by 2 pi mr. Say it is equation 1. Next, so where r is equals to radius of nth orbit, we know that it is can be represented like this: Rn is equals to n square h square by 4 pi square m z e square. Okay, substitute the radius of nth orbit in the above equation, that means in equation 1. Okay, now substitute, right? V is equals to nh by 2 pi m. Okay, done. This is r is equals to n square h square. Okay, so 4 pi square m z e square. So after cancellation terms, so v velocity of the electron in the nth orbit, is equals to 2 pi z e square by nh. Okay, so substituting the value of pi, e and h. Okay, so the velocity of the electron in the first orbit of hydrogen is calculated like this. This is in first orbit of hydrogen. Now velocity of the electron in the nth orbit of hydrogen. Velocity of the electron in the nth orbit of hydrogen. Okay, this is the basic equation we have. Okay, now let us, yes, okay, it is first orbit. Now velocity of the electron in nth orbit of hydrogen only, nth orbit of hydrogen, that is equals to velocity of the electron in the first orbit, that is 2.188 into 10 to the power 8 centimeters per second. Okay, it is done by n. Suppose I want to calculate velocity of the electron in the third orbit of hydrogen atom, so it is by 3. Suppose if it is, I want to calculate velocity of the electron in the second orbit of hydrogen, that is by 2. Okay, this represents velocity of the electron in the nth orbit of hydrogen atom. Okay, nth orbit. So orbit, second orbit, third orbit, fourth orbit, fifth orbit of hydrogen only. Okay, now species like hydrogen, velocity of the electron in nth orbit of species containing one electron, like helium plus, lithium 2 plus, beryllium 3 plus, for these species which contain one electron, that is equals to velocity of the electron in the first orbit, velocity of the electron how much? 2.188 into 10 to the power 8 centimeters per second. Okay, velocity of the electron in the first orbit by nth orbit into z. This speaks about velocity of the electron in any orbit which contain one electron. Okay, into z, that means atomic number of that particular species which contain one electron. Okay, suppose calculate velocity of the electron. Let us substitute the values in one example. Okay, so this is velocity of the electron in the first orbit of hydrogen atom, and this is velocity of the electron in the nth orbit of hydrogen, that is by n. Next, this is velocity of the electron in the nth orbit of species containing one electron into z. Okay, done. Let us take up two examples. Let us exercise. Okay, calculate the velocity of the electron. Calculate velocity of the electron in the second orbit of, or let us say calculate, let us write the problem. Okay, calculate velocity of electron in fourth orbit of beryllium 3 plus, in fourth orbit of beryllium 3 plus ion. That is a problem. Calculate the velocity of electron in fourth orbit of beryllium 3 plus. Now substitute velocity of the electron in the fourth orbit, velocity of the electron in the fourth orbit of beryllium 3 plus, that is equals to 2.188 into 10 raised to 8 centimeters per second by fourth orbit, so by 4 into z. Atomic number of beryllium is 4. So yes, that is equal to 2.188 into 10 to the power 8 centimeters per second. That means velocity of the electron in the first orbit of hydrogen, that is equal to the velocity of the electron in the fourth orbit of beryllium. Okay, should remember that. Like that we can calculate the velocity of the electron in the nth orbit of species containing one electron. Okay, this is about velocity, calculation of velocity of an electron in any given orbit containing one electron. Okay, the atoms, the species containing one electron. So that is velocity of an electron. Next one is calculation of number of revolutions. Calculation of number of revolutions. Yes, calculation of number of revolutions. Calculation of number of revolutions of electron. Number of revolutions of electron in any orbit. In any orbit. Okay, calculation of number of revolutions of electron in any orbit per second. Yes, done. Per second. Okay, now let us write this velocity of the electron, because it is useful now, because that is velocity of the electron in the nth orbit is equals to 2 pi z e square by nh. Okay, let us write it separately. Right. Next, velocity, that is calculation of number of revolutions of electron in any orbit per second, that we can calculate it as number of revolutions per second is equals to, so that is velocity of the electron by circumference of orbit. Okay, number of revolutions per second, number of revolutions per second, that is equals to velocity of the electron, velocity of electron by circumference of the orbit. Circumference of the orbit. Yes, that is equals to, simply we can represent, that is V by, that is velocity of electron. Okay, that is any orbit. Okay, so that is equals to V, velocity of the electron in any orbit, that means nth orbit, by circumference, that is 2 pi r. Okay, circumference of the orbit. Okay, now velocity of the electron is given by, there we have already represented, so that is equals to, number of revolutions is equals to velocity of the electron, that is 2 pi z e square by nh into 1 by circumference of the orbit, 2 pi r. Okay, 2 pi r. First we substituted, that is velocity, then r, where r is equals to circumference of the nth orbit. Circumference of the orbit, that means nth orbit. So that is, as we know that radius of the orbit Rn is equals to, that is n square h square by 4 pi square m z e square. We know this. So this is radius of the orbit. Now substitute the radius of the orbit in this. Okay, so therefore that is equals to 2 pi z e square by nh into 1 by 2 pi. Now we have to substitute r. R is equals to n square h square by 4 pi square m z e square. Okay, now this is the, now let us cancel the similar terms on the opposite side. Okay, say for example it is 2 pi is cancelled. Okay, next let us see, number of revolutions is equals to, let us write here, number of revolutions in any orbit per second, that is equals to, this is equals to, yes, what left, so 4 pi is C, yes, we have 4 pi square m z into z square, e square into e square, e to the power 4 by n square into n cube, h square into h cube. This is the equation we can use to calculate the number of revolutions in any orbit per second. Okay, that is 4 pi square m z square e to the power 4 by n cube h cube. Okay, so the important relations we should remember, this is, we have done radius of the orbit in hydrogen atom and 1 electron species, and energy of the electron in given orbit and species containing 1 electron, and we also done velocity of the electron in the nth orbit, okay, of species containing 1 electron. Now number of revolutions made by an electron in any orbit per second is also completed. And coming to the next concept, see in this, so that is number of revolutions per second, that is equals to velocity of the electron by circumference of the given orbit. Okay, so velocity of the Vn by 2 pi r. So substituting all the values, so we can find out the number of revolutions in any orbit per second can be given like this. So we have a beautiful numericals on these concepts. Okay,